Hi, my name is Jialin Deng from the Exertion Games Lab at Monash University in Melbourne, Australia. I am presenting our work on the logic Bonbon exploring food as computational artifact. Over the last couple of decades, we've seen a growing trend in which culinary designers are exploring novel combinations of computing and food to create engaging interactive eating experiences. For example, using AI and mobile phones to track one's eating for healthy diets, hiding music devices around the dish to create multisensory eating at the fine dining restaurants, combining sensors and video games to gamify eating, using mixed reality to hack diners' senses, and installing multimedia devices to create immersive dining experiences. However, most existing approaches of interactive food systems position technology around ready-made food, and consequently, such technology-driven experiences are dependent on the digital devices rather than on the experiential affordances of food. This is evident by the fact that these systems typically work without the food, and the diners do not even need to consume the food to have a digital experience. We believe that this limits making full use of the potential of celebrate the pleasurable and enjoyable experiences that people have with food. Hence, our goal is to understand the material integrations through the design of food as computational artifacts. Therefore, we explore designs in which food as a material is the medium by which computation is realized. We propose the material integration as an approach to understand how computation can be realized through food's material qualities. Through this understanding, we hope to open future opportunities in advancing HCI for new user experiences by implementing food as computational artifacts. This raises the question, what does it mean for food to have computational qualities? Our first attempt was to investigate how can we design food that are computational artifacts. To answer the question, we demonstrate our research through design exploration of food as computational artifact through the design of our first prototype called the logic Bonbon. It is a liquid-centered dessert that can perform computation in the form of logic operations induced by the dynamics of edible fluids. Consequently, it enables a real-time tailoring of food experiences by empowering the diners to modify the food's taste and visual presentation just before they eat. Taking inspiration from previous works on fluidics, we present three designs of the logic Bonbon with three fluid-induced logic functions, AND, OR, and XOR. Each logic gate has a unique fluidic configuration. These simple logic functions are the basis of any computers that, in this research, enable food to regulate its own flavor and visual appearance. Each basic unit of a logic Bonbon system consists of a set of input and output modules that can be independently created and exchanged. The logic Bonbon itself can be regarded as the output module, which is designed in a multi-layered structure for regulating the fluids inside. Each logic Bonbon has a specific fluidic configuration that determines its logic function. Here's an example of how a logic Bonbon performs an AND function. When only one input is on, that is, the diner presses only one of the pipettes with one flavored liquid. The liquid travels through the logic Bonbon, coming out on the other side into the recycler, and the logic Bonbon remains flavorless. However, when both inputs are on, that is, the user presses on both of the pipettes containing two different flavors, the liquids mix inside the logic gate channel and go up to the output chamber, which in this case displays a heart shape and makes the logic Bonbon taste with a mixed flavor. To achieve this, we created a set of silicon molding tools for casting each layers of the logic Bonbon. We also tested 3 recipes with 3 different gelling agents to make the logic bonbon. The ingredients are suitable for construction and shaping during molding, and the working surface of the material is durable enough to retain liquid fillings, and also the recipes have been generally acknowledged to be tasty. The integrated computation allows food makers to program food that enables diners to execute the embedded functions through novel interactions with the food. Our study on experiencing the logic bonbon uncovered that food computation integration facilitated novel experiences by enhancing playfulness, reinforcing social bonds, and promoting a flavorful learning experience by eating. Based upon our research designing, crafting, and studying the logic bonbon, we have formulated an initial set of design considerations for creating engaging human-food interactions with food as computational artifacts. With exploring food as computational artifact, we envision new ways of innovating our dishes and food products that can computationally change their material configurations for a real-time tailoring of personal food experiences, ultimately to shape the future of food and computation.
Let's see if you win. 3, 2, 1. That's cheating. Oh, cheetah! It was pretty.
Well, there's more yellow outside the logic.
It must be more red.